Okay, so another real quick example, same, very similar to the first one, the previous video that we just did. I just want to run through it one more time, give you a chance to practice it yourself. So if you're working through this video and you kind of see where I'm going, definitely pause the video, fill out the rest of the table, come up with an answer, and then come back and see if what you're doing matches up with what I'm doing, because that's the goal here. So um, yeah, here's another example of KEQs calculating from initial and equilibrium concentrations. So once again, we're going to use this table where we have the initial, the change, and the equilibrium. If we go down the side here, right, this is what we call an ICE table. So if you ever hear me refer to an ICE table or an ICE table calculation, this is the kind of thing. You're going to plug in the information that you're given, you're going to find the changes in concentration and use that to figure out equilibrium concentrations for everything else. In this case, again, we have a different reaction. We have N2O4 decomposing to two molecules of NO2. And in this case, we're given an initial concentration and an equilibrium concentration of the same component of our reaction. So we can fill that in here. The initial concentration of N2O4 is 0.2 molar, right? And the equilibrium concentration is 0.057 molar. If you're not given a concentration, initial concentration of product, it's safe to assume that it's zero. If you were adding product to your reaction before it started, that's something that would be mentioned or given. Right? So we only have three squares left to calculate. The two squares in the NO2 column, we're going to have to wait on, but this change in concentration for N2O4, we can definitely figure out. We take 0.2 minus 0.057, and we get 0.143 molar. And because this is a reactant, we make that negative. So we have a negative uh, change in concentration for N2O4. And now we just need to figure out what is the change of NO2. And this is again where we go back to our balanced equation. So when we are finding change, we use the balanced equation. Right? So the balanced equation tells us that for every mole of N2O4 that reacts, we produce 2 moles of NO2. So to figure out the change, we would take this time, that's 0.143 times 2. And that would give us our 0.286 molar. That gives us our change in NO2, right? So because this coefficient is 2, right, we multiply the whole thing by 2. This is similar to what we did in the previous example, right, where we said the change in HI is 1/2 of the change of H2, only this time we were given the reactant, and so we just multiply the change in the reactant by 2 to get the product. And then, of course, we do 0 plus 0.286. That one I feel pretty confident in. So my equilibrium concentration of NO2 comes out to be 0.286. Now, to calculate KEQ, first we need a KEQ expression, which we haven't come up with yet. But if you're thinking ahead, I'm sure you've got it, right? Products over reactants. And now we just plug in our equilibrium concentrations here. So our equilibrium concentration of our product is 0.286. So that squared divided by 0.057 is going to give us our KEQ. And in this case, we get a KEQ that's actually pretty close to 1.44, if you calculate this whole thing out. Right, so that's our KEQ there. And so what that tells us is that at equilibrium, there's a pretty even distribution of N2O4 to NO2, right? Or this reaction doesn't really favor products over reactants or reactants over products, right? There's still an appreciable amount of both of them around in the reaction. So, which is interesting, but that's kind of the takeaway from all of this. So these two examples that I just did, the previous video and this one, are pretty straightforward versions of ICE tables, right? But I want you to get used to the idea of thinking about these reactions in terms of how does the concentration change from our initial conditions to the equilibrium conditions. Because when we get to acids and bases, that's what we're going to do. We're going to change those conditions, and by adding more acid, we're going to change what the what the overall concentrations are, and we're going to need to know our equilibrium. Once we know our equilibrium constants, we can use that to predict what happens, etc., etc. But the first thing is to get comfortable with the idea of the change in concentration of our reactants and our products, and how that's governed by KEQ. All right, so there will be a couple more examples using ice tables that I'll do, and then that will wrap up our introduction to equilibrium.